All right, hello. So in this video, I'm going to walk you through the steps for setting up and running this eye tracking client. So a couple quick notes though, before I really get into it. I've only tested this on a couple of computers, so I don't know how well it's going to work on other systems, especially those with weaker hardware and AMD hardware. I don't know for sure. Maybe it works, maybe it doesn't. If it doesn't, I can work on fixing that. So another thing, second note, you're going to need firmware for your iTrack VR hardware that is newer than March of 2024. Earlier versions had a bug in it that will make the cameras not connect. And third, final thing, currently I only support connecting directly with an IP port. I don't have support for MDNS or for COM port connections at this time. If there's interest, I can add that, but haven't needed it yet. So first to get started, first thing you need to do is on the repo, you're going to want to download the latest release. So you can pull that from the zip here. Don't get the source code, just go for the zip. I've already downloaded it here. And inside of it, you're going to find three files in a folder. Each of these, they're different parts of the total overall system. So the first thing, this is just this executable is the installer for the client. And then you've got three other folders. VRTA, this is a Unity application for generating the training data set for your model. Then you got a trainer, this is a Python script and like a wrapper UI for training your machine learning models based on the training data set you generate. And then the converter, it's another Python script that converts it from the H5 file that the trainer creates into a format that the client can read. So to start, you're going to want to extract all of this stuff. And I would avoid extracting this to like a cloud synced folder. I've had some issues with that on the development side. So for now, I'm just going to put this into a demo folder that I've just put on my hard drive, just not inside of a cloud folder. So select that, extract it, take a moment. All right, and I'll close this part out. So now you're here with it extracted. First step, you can just install the client. Just double click that, run it. The client will install, it'll start up after it's installed, and then minimize this. So you may want to also create a shortcut on your desktop for this. If it doesn't create one already, it'll make it a little bit easier. All the settings and stuff will persist. So you won't have to worry about like doing it fresh every single time, even if you reinstall it. So you got three tabs at the top and then settings. So in your settings, you can set things like your theme, you can set your display language if you'd like to. It's not 100% perfect. I don't know if the translations are fully correct, but I wanted to make sure that I have the support for it in the future in case anybody wants to use it. You can also set a background image for the application if you'd like, and that'll work across the other themes. So then outside of settings, you got three tabs. You got your status tab, database, tracking, the status tab, that is for managing your camera connections. Then the database tab, that is for handling data collection for your machine, basically for the data that you'll need to train the machine learning model off of. It's for collecting that, or for sort of collecting that data, selecting the database you want to save it to, and also selecting the model that you want to use when you're actually doing tracking. And then the last tab, that's the tracking tab. This is for managing and tracking in VR. It gives you various control options. I'll go into that later. For now, though, start the status tab. Now you're going to want to connect your trackers, your eye trackers at this point. Leave this port here for headset tracking. Leave that at the default. This is the port for connecting to the Unity application. Right now, it's not configurable on the Unity side, so just leave it at the default or it won't connect. And then you're going to need to enter your IP and port address for your left and right cameras here. I've already got them pulled up here on this little notepad for me. And at this point, you can have your trackers on. They'll automatically connect once you put in your IP and port. So you can put them in, and you should see, if everything's set up, you should see your your camera's connected on these two little windows, and you can see my hands there. It'll automatically connect. It'll automatically reconnect if anything goes down. Like if you get the port wrong or something, it's mistyped, and fix it, it'll reconnect. If you like physically go in here and turn the tracker off, turn it back on, it'll connect. And once you got this set up, also you can force them off and online by clicking these cards at the top. Once you got your cameras connected, then you're pretty much ready to move on to the next step, which is going to be building a training data set for your machine learning model. So you're going to need to collect some data, and that's going to require you to be in VR using the Unity application, which is a little very, very small Unity application for VR that will connect with this client to generate your training data set. So I'll move on to that in the next step. Okay, now I'm in VR for the next step, which is to generate the training data set that you'll need to train the machine learning model. So you're going to want your headset on with your eye trackers on and connected. So I just turned them on there and you can see they're working. So next thing you're going to want to do is go down to the database tab. Now in the database tab, you're going to need a database in order to train your model. So I'm just going to create one here. I'll call it test for now, but you can give it a name that you like. And I'm going to just pop this onto I'll just drop this onto my desktop up here. And now you'll see I now have a desktop. I now have it set. It shows it there on my screen. If I move it onto my desktop, you can see I've now got this new database file. Oops, there we go. So what you'll do here, next thing you'll need to do is you'll need to open the VRTA application. This is the Unity application for eye tracking. So go to where you saved your thing. In this case, I saved mine or where you extracted your files. Go to VRTA and open up this application. You can open it up through Steam Link, through Virtual Desktop, probably through AirLink too. You just want to run it. It'll start up. And now you can see really just a really empty Unity scene all around me. There's pretty much nothing here except for this dot. Except for this dot. Now, what this dot is the sort of thing to look at, okay? So you're gonna want to step away a little bit. Give yourself maybe 20 feet or so. And now, if you look in your training application, sorry if the screen kind of jumps a little bit as I manipulate it. So now if you look in the status tab, you should see that the VR headset tracking card on the top right, as I toggle it, is now on, and it shows some data there. That means it's connected. That's good. So now in database, you're going to also see this theta flags section. This is the specific control flags that are sent from the Unity application to the client. And it has two modes. It's got a gaze mode and an openness mode. It also has some different flags for recording data, for deleting your recent data, and for an openness value for controlling or for training blinking. So to start, you just want to start with the gaze tab and some things to note. So in here, on your controllers, you've got a few controls. So to start is the recording control. In order to start recording, you're going to want to hold both of your grips. You're going to want to hold them down for at least 1 second. Once you're holding them for 1 second, you should see that the record flag is going to switch to true. That is when you're recording data. Second thing is if you're to click your right controller's A button, that is going to delete the most recent 10 seconds of data. And then the B button will switch between openness and gaze mode. So I'll start with openness mode. So for openness, what you're going to want to, or sorry, for gaze. For gaze, what you're going to want to do is you're going to want to stare, you're going to want to look at the dot. So you're going to look straight at the dot, And then you're going to want to turn your head in a sort of sweeping pattern. So while staring at the dot, you're going to want to sweep your head in such a way that the dot, you will get training data for you looking at the dot from pretty much every visible angle. And to train that, you're going to want to start by hitting the record training data button. Once that's checked, you're going to hold both grips down, hold both your grips down, and then it will start recording. And you'll see the number. You'll see the number here under number of entries. This number will start to go up. So I'm going to start recording now. And so I'll turn my head to the right, turn my head to the left. And once I've gone through that, I'm going to move my head up a little bit. And so this entire time, you're just going to be staring at the dot. You want to look at the dot, look at the dot, look at the dot. Don't look at anything else. And so you're going to do this for a suitable number of samples and for a suitable amount of your field of vision. I'll show you an example in a moment of what a good data set would look like. I personally, for myself, aim to have around 20,000 data points. And so once you get to the bottom of your screen, you can then do the exact same thing, but going up. And I won't record too much data because this can take 20 minutes or so in order to get the data that you want, in order to get a good data set. I'll just record this single pass through of my eyes. Okay, so I've recorded that. Now, after this, you see I've got 2,000 entries. So if I were recording for 20,000 entries, I'd probably do something similar for, 10 more times. I would maybe look up and down. Maybe I would look side to side or like at like an angle. Maybe I'll do spirals or something different just to get that number up. Next thing is the openness mode. This is a little bit more complicated than gaze. You don't need to worry about the dot for this. Instead, you want to worry about your trigger. And as you press this trigger down, you'll see that the openness value will decrease. And in VR, there's actually a display that'll also give you some information too that you can't see on the screen right now. So what you're going to want to do is you're going to want to close your eyes at the same rate that you depress this trigger. So if I were to pull up the status tab, for example, you're going to want to slowly close your eyes at the same rate that you press that trigger down. And what this is doing is it's sort of saying when your trigger is halfway closed, that represents my eyes being halfway closed. When the trigger is fully shut, my eyes are fully shut. When the trigger is released, my eyes are at a neutral openness level. So you're going to want to record training data for this as well. And to start recording, once again, you're going to want to make sure that 1, you're connected on this card. That's green. 2, you're going to want to make sure that this record training data flag checkbox is checked. And the last thing, both your grips are going to be held down. So I hold down my grips and then I'll slowly depress the right trigger. Slowly depress this right trigger while slowly matching my eye blinking. And you want to blink both eyes at the same time if you have them. If you only have one eye, that's also okay. So I'll give some samples of it now. So trigger's held down, and then I slowly blink. And this can be a little bit complicated or a little bit difficult. It might take you a couple of attempts to kind of figure out the flow for this. Now, I'm not going to do too many. I'll just do, 700, I suppose that's the number. Now, when you're doing this, you're going to want to also make sure, I'm going to pull up the status tab again. You're going to want to make sure that you generate blinking data at various directions. So if you were to look to the left, you're going to want to generate some samples there. If you look to the right, you want to generate some samples there. Same if I look down, same if I look up, same if I look in the other corners. You just want, and maybe somewhere you blink normally, and some where you squint. You close your eyes via squinting. And it's a similar thing with gaze, too. When you're doing gaze, on the other hand, maybe you want to train some gaze sample data with your eyes a little bit squinted, or with your eyes wide open, or maybe somewhere in the middle. And feel free to blink normally as you're training data. Then if you make any mistakes too, you have a 10-second window where you can click the A button and that'll delete the most recent data. So I know this is complicated. This is the most complicated step of the whole process. But at the end of it, you'll have a data set that you can then use to train your model, and the model is going to be a lot better than with a nice clean training data set that's built off of your own eyes. So I'll go to that step next. And for that, you're going to want to go back. You're going to want to jump out of VR, go back to your desktop, because the training process is pretty computationally intensive. So I'll have that pulled up next. Okay, so I'm back on my desktop. I've got the Git repository pulled up again. So you're ready for the next step. This is training your machine learning model. So if you scroll down in the Git repository on the README to the training section, you'll find the instructions for this step there in text form, but I'll go through them here in video as well. You're going to need to install both steps 1 and 2. Install Visual C++, install Miniconda. The training process uses TensorFlow, and so the environment for that is a bit complicated. This makes this actually feasible for me to walk you through the installation process of it all. So to do this, once you got these two installed, I've already got them installed on my computer. You're going to want to open up through your start menu a thing called Anaconda prompt. PowerShell prompt or command prompt. I'll use PowerShell. What this is, what Anaconda is it is an environment manager for Python. The installation process for TensorFlow is very painful, and installing everything yourself is an absolute nightmare. Using a manager like Anaconda makes it much, much easier. Once you got it pulled up, you're going to want to follow these steps on the right, on the left. And to start, you're going to want to choose where you want to install your environments into. I'm just going to install them into this demo environment. So I'll just CD to my desktop, to my C drive, to the eye tracking demo directory, and then follow these steps here under section 3. Type conf create -p, that's a path, tfgpu python 3.10. So this is installing Python in, proceed, we'll install everything. You don't have to follow all these steps every single time. Once you have your environment set up for this and for the training section, then all you're going to have to really do is just activate the environment and then run the Python scripts. It simplifies the process. So now I've got the conda environment made. Now I need to activate it. You can see here the tfgpu folder now exists. So I can type in conda activate tfgpu. And if you look on the left, I've gone from base to tfgpu. So now I'm in the now freshly created conda environment. So once I'm here, run that next command. I'll just copy paste this. You only need to run this the first time. This is installing CUDA. If you want to run the training off of your GPU, I'd recommend it. It'll be a lot faster than running it off of your CPU. Although the installation is a bit big. I think it's about a couple hundred megabytes. So there we go. I've got my CUDA installed. Next thing, I'm going to CD into the trainer directory. So CD trainer. Now in this directory, you have two things you can run. So really you can run all these scripts, but the big ones, there's a heat map generator for looking at your training data set. I'll just go through that one really quick. You just type py or Python and then run the script that you want. So to start, I'll run the create gaze heat map script. Okay, I skipped a step. I need to run pip install upgrade pip first. So if I don't get ahead of myself here, and it'll complain. It'll say here, run this thing instead. I'll just copy that, run that instead. All right, once you got that done, make sure to follow the next step, pip install -r requirements.txt. Now this is actually going to do the installation process of installing TensorFlow, like pyplotlib and all this other stuff. This is what Anaconda is saving you from having to figure out how to manage. It'll take a minute to install, but once it's done, then you're good, as long as you keep that environment. So in this directory, in the training side, there's a bunch of scripts. There's a UI wrapper and a heat map generator. Those are the two important ones. The rest of them are called by the UI script or by the UI wrapper. The create heat map script will generate just a picture file representation of the training data set that you've created, so you can visualize your training data and see, okay, is this probably going to be a good data set or is this going to be a bad data set? I'll show you some examples here. So once you're all updated, you can run Python, and then in this case, I'll do create gaze heat map. It's going to ask you for you to give it your database input. I'm just going to pull up that test from earlier. It'll ask you for an output. I'll just call it heatmap.png. This will be probably not a great data set since I made it in about 2 minutes. And it'll put it on your desktop. So I can pull it up here and open this picture up. So you can see my data set, not that great. See, there's a lot of dead space, but overall, I mean, it's about the right shape, but there's definitely a lot of kind of data I don't want to fill in. I mean, this is all part of me only having 2,000 samples. So that's represents 2,000 samples. I'll run this again, but instead of that, I'm going to pull up the actual data set that I use personally. This is my database. See, it's a much larger database now. And I'm going to drop this one onto my desktop as well. I'll call this heat map good. So now I've got heat map good. If I open this one up, you can see the difference here. I've got, in this case, I've got a lot more data towards the center, but also I have a better, more even distribution along the edges. And this is a little over 20,000 data points. So you're gonna want a data set that's a little bit more towards the, like a little more on the right, a little bit less on the left. And if you see any spaces where you have just not enough data, you can go back, you can add more data to it. So next thing you got, aside from these heat maps, is the main UI script, python./UI. This is the training part. This will take a moment to start up. And this will open up a UI for generating your TensorFlow models. So you'll select your training data set. I'll just select this test data set because it's a quick and dirty one. You'll select your output. I'll just throw this onto my desktop. So your input data set, your output folder, and then you can choose what you want to train. So in here, you get a bunch of options, and depending upon what your hardware setup is and what you want to do will kind of define the models you want to train. So if you have only one eye, let's say you only had a left eye and you didn't have a tracker for your right eye, you would say, I just want to train my left gaze, my left openness, and maybe you might say left openness Gen 2. That's probably what I would choose, train those three. If you have both eyes and you want to train the full, complete, best possible model for everything, then you're going to want combined gaze, combined openness, You're going to want left gaze, right gaze, and then you're going to want to also use these models that you've trained to generate a second generation of model for better tracking. So what happens is it'll train one model and then it'll use the output of that model as sort of a guide for training a new model that's even better. So for that, combined openness Gen 2, and then these two distillation models. So combined gaze, combined openness, left gaze, right gaze, combined openness Gen 2, left openness, combined Gen 2 distillation, and the same for right. This will be your best 2i setup. Hit start. You can minimize this, you won't need it. And then you can look on the terminal, things will start to train, as will your CPU start to suffer. Now this will train pretty fast because I don't have a couple thousand data samples and I'm not even going to wait for the whole thing. But now you can see it training. You can see the model's going to improve over time performance-wise. This will train now 9 different models back to back since I selected 9. If you have a full data set of 20,000 plus gaze entries and 20,000 plus openness entries, this could take a few hours to train. So maybe go to the grocery store, take a shower, go exercise, go on a walk, something, because it'll take a little minute. It'll take a minute. And once it finishes one model, it'll move on, train the next model, train the next model, train the next model, until it's all done. I think I'll leave this here for just one model, and then I'll X out of that, skip to the conversion process, and just use my existing good models for that conversion, so you don't have to wait through training again, all this stuff. Okay, so from here, it's training, it's training, it's training. I'm just going to X out of this, kill the application, go back up one level. So assuming your models are all trained, you actually can see here on my desktop, it created one of them, but I'll close out of that for now. You're going to want to now convert those models. And when you convert them, you're going to need to use the converter folder instead of the trainer folder. And you're going to need a separate Anaconda environment for training. So you cannot reuse the same Conda environment. If you do, you're going to have problems. It's a bit frustrating, but the TensorFlow version that trains the machine learning models is not compatible with the TensorFlow version that converts the models to TensorFlow.js, which the client is able to read. It's annoying. So you go down here and you'll need to walk through some of those steps pretty much all over again. Conda create -p, give it a different name. I call it TFJS, TensorFlow.js, Python 3.10. This will create a new Conda environment. Once again, say yes, proceed. I'm going to activate this. TFJS. Now you see on the left, on the bottom left, it went from TFGPU to TFJS. That means I'm now in the new Conda environment, which is good. You're going to need to install CUDA again. Again, not strictly speaking necessary, I think, but I recommend it. This will take a minute, but shouldn't take too long. All right, that's installed. Now you'll go this time instead of going into CD into the converter, you'll CD into trainer. Now in this directory, sorry, I misspoke there. You'll CD into the converter directory. Now in the converter directory, you've only got one script to run, convert to tfjs.py, but before you do that, you're going to have to run the pip install commands first time only. You're only gonna have to run this the first time. Once again, it'll complain. Just copy, paste that. Pip install -r requirements.txt. Again, I'm following the instructions here on the left. All right, this is installing the different TensorFlow version and the dependencies that it requires. Once again, it'll take a minute. And I know up here some of the stuff is a little bit like this shouldn't be training, it should be a converter. So I'm going to fix that before I publish it. So you won't see this little mistake right here and the README. That'll be updated by the time you see this video. Once this is done, you'll cd into that converter directory if you're not already there, and then you can run the conversion script. Should be done in just a moment. Or not. There we go. So that finished the installation. Now I'm ready to convert the models that I trained just a moment ago to TensorFlow.js so I can import them into the eye tracking application. So you run Python, convert to TF.js. This will take a moment to start, but it'll open up another UI. Here we go. Now I've got a new UI open. Select your input folder. This is where you created those H5 files. So it was the output folder of the previous step. I'm going to use models that I've already trained. So I'll call it trained models in here. So this is, I'll pull this up on my desktop too, so you can see what's actually in here. So in here under database, under trained models, you can see a bunch of H5 files. These are my models that I've trained off of my good data set. So I'll select that folder, and then from my output folder, I'll just dump these on my desktop. And then you select the models which you want to use or which you want to convert. You have up to six different models, one for your right eye, one's for your left eye, and one's for both eyes together for each of blinking and gaze. My recommendation is if you follow the step that I had previously, you're going to want to use combined open is Gen 2, left open is distilled, right open is distilled, and then the combined and left to right gaze. Convert. It'll convert all of these, and then on your desktop you will have a bunch of these models that have been converted. This now is what the eye tracking client will load, and I'll show that step next. Okay, now I'm back in VR. This time to show you how to connect the final step, which is using your models, selecting them, and then configuring the tracking and using it. So first thing you want to do, select your models that you converted in the previous step. I converted those into my desktop, so I'll select that. And once you're done with that, next step, you're going to go to the tracking tab. So in here, it'll depend, what you use will depend upon whether you have a native VRC face tracking V1 or VRC face tracking V2 avatar. And so for example, this is a VRC face tracking V2 avatar. And if you have native, then you'll just toggle the native option, and that'll send the eye tracking gaze data and the blinking data over OSC parameters for native. And it's the same for VRC face tracking 1 and 2. And then the split Y out checkbox below that determines whether it should send the parameters with only one Y value, like there's a separate X and a separate X value for both eyes, but there's only one singular Y value, or whether there's two values for each eye. And you can pull that up. Oh, sorry, I'm drifting a little bit. You can pull it up in your debug menu. I don't know how well this will be visible for you all, but if you open this up, and let's see, somewhere in here, sorry, try to figure this out. In your debug menu, you can find the parameters for your eye tracking. Here we are, I found them. All right, so in here, in that debug menu, you can see like, oh shoot, sorry about that. You can see eye left X, eye right X, and then the same eye right X, eye right Y. So that's a split Y output. And if you don't have that, if you just have only one Y value for both eyes, then you're going to want split Y out to be toggled off. So for this one, keep it toggled on. So close that away, close that up. I'm drifting. All right, so with that done, the next thing that you're going to want to do is, let's see, well, I guess I can just go through the other various setting options. So the gaze configuration, sorry, my right eye tracker is, my cable I'm pretty sure is a little bad, so it's disconnecting pretty frequently. Anyway, okay, so let's start with how about openness configuration at the top. So what you see here on openness configuration, you see a single slider with 4 separate handles on it. Each of those handles represents together they represent really 5 separate like windows. So between 0 and 0.2, which is the smallest value here, that represents how the value range when your eyes should be treated as fully shut. So if I were to drag this value all the way up to the right, my eyes are going to be shut pretty much all the time. And then if I drag it down, that'll change the range for my eyes to be, only shut when they're actually shut. And that's kind of what you should configure, is like you should configure the range so it's shut when your eyes are shut and open when they're open. Then the second range here, now between 0.2 and 0.65 on my UI, that represents the range from where you should have a smooth transition between a neutral, which is in OSC, that's a 0.75 output value, and fully shut, which is 0. So anywhere between those two values, it'll smoothly interpolate. So you can have the ability to kind of slowly close and open your eyes. Then that third range, which for me is between 0.65 and 0.96, that's the neutral openness value range. Anything in between that range will just be output as 0.75 in OSC, which is the neutral level. The next two ranges, it's the same as the before, a smooth interpolation between 0.75 and 1, which is like going between neutral to wide open. And then the last range is between that last handle in 1, which is fully open, fully wide open. Now, I don't have really a system set up yet for training the widening of your eyes, so that value is probably best if you just kind of shove it off the screen for now, as I've done, and just go between neutral and blinking. So that's that. Next thing you got the gaze configuration section card below that. Vertical and horizontal exaggeration. What they will do is they will kind of dampen or exaggerate the horizontal and vertical motion of your eye. So if I took horizontal exaggeration and put it down a lot, and then I look all the way to the left and all the way to my right, my eyes don't move very much. Whereas if I took that slider and I cranked it now all the way to the max value, now if I look all the way to the left and all the way to the right, my eyes move very, very fast, like large amounts. I'm going to set that back to 1. Okay. Then you got pitch offset. This one's also pretty self-explanatory. You're able to offset your output values vertically for your pitch. If your avatar kind of is looking all the way always up or always down a little bit, you can kind of tune your setting there. Blink release delay below that. This setting will, when you blink and when you shut your eyes, it will wait that many milliseconds after your eyes are no longer shut before it'll stop being shut. Sort of what this is designed to do is allow you to overcome any latency issues between, for VR chat's OSC rate. From what I've heard, OSC is about 10 messages per second is about the rate you should expect, which means that if your tracking rate is really, really fast and you blink really quickly, that blink might not actually make it through to remote users because your eyes will be going down and up before you'll get a tick, in a sense. Like it might be tick, your eyes shut and then open, and then tick, and your eyes are halfway open by the time you get another tick. So your eyes will never fully shut for a remote user. So what this will let you do is kind of tune that value. So if you drag it to the right, if you drag it to the right, when you close your eyes, they'll stay closed for a little bit longer. Of course, now it's looking a little bit ridiculous. Okay, there we go. So now, what else do we got? And you can disable this behavior if you just drag that all the way down to 0. Tracking rate, self-explanatory. Although really the tracking rate is, for this application, it's mostly limited by the frame rate that's being transmitted to you from your trackers. So I've seen that about like 30 to 40 FPS stable connection from both my left and right eye at the same time. I'm not even running at like 30% load on a single core. Granted, I use 3 cores, but 2 of the cores are only running at about 20% for me. The main core only still hits about 30 to 40%, so there's a lot of headroom in there. If you drag this all the way to the right, you're going to cut your eye tracking rate down pretty significantly, and same with dragging it all to the left. Now, smooth tracking versus less smooth. Okay, so that's that section. Now, talk the Kalman filter section. This is for smoothing your output values. If I turn all of these settings off and then get a little close to the camera, I don't know how well this is going to show, but you might see that my eyes, at least the output values, might vibrate a little bit. And that's because there's a little bit of noise inherent with the readings. So you can filter that noise by turning the smoothing on. It's similar between smoothing your eyes and openness. They're both the same, but one controls like your gaze, your left, right, up, down. The other controls your blinking and how much they smooth there, or whether it's enabled, sorry. Then you've got a threshold value and some filtering parameters for each option. So how this filter works is based on whether the motion is large or small, determines on whether it should be filtered like at different levels of trust. So very small movements, very, very small movements are treated as if they were noise, whereas very, very large movements are treated as if they're like a new ground value. It's kind of new truth. So that threshold, though, is determined by threshold gaze and threshold openness. And then the amount of smoothing in particular for each is controlled. Q low, that controls the smoothing for below the threshold, and Q high determines the smoothing for above the threshold. What it really comes down to in practice, I've seen is about Q high is the only thing that's really going to be a big noticeable impact. If I turn it all the way down, then there's going to be pretty aggressive smoothing applied to my large eye movements, like if I look just left to right, or if I turn it all the way to the right, or close to it, it'll be much snappier. I sort of like to leave it right in the middle because I like my big movements to be pretty snappy. Last option there, openness-based trust. What this value does is it will change the filtering and treat the gaze value, so where you're looking X and Y, as being less trustworthy the more squinted or shut your eyes are. So if your eyes are fully shut, it won't trust your gaze reading at all. If your eyes are pretty close to shut, it'll treat the gaze reading as being far noisier. It's designed to reduce kind of a jump effect where as you blink, like your eyes sort of jump to the side because the tracking isn't very great when your eyes are extremely shut. So that's that. My recommendation, you can probably just leave them all on or leave them all off. I don't know. You can tune that how you wish. Then you've got last things I haven't really gone on to yet. Independent eyes, independent eyelids. These are both self-explanatory. Independent eyelids, if you turn that on, it'll track your two blinking values for your left and right independently. This will allow you to wink. You can close one eye, you can close the other. You can kind of squint different levels. It's there's still a little bit of desync where if your two eyes you blink them at the same time, they may not blink at the same time because the cameras don't necessarily update at the same time. Like, they might be offset or whatever. One camera updates now and then now and then now and then now. I have some thoughts about how to fix that, but I haven't really dug into that too much yet. And then independent eyes, that's the same thing as independent eyelids now, just for your gaze reading for left, right, and up, down. It'll still use the combined value for your Y, so your two eyes won't they won't separate, and like one will look up and the other one will look down because that's not right. But it will allow you to do things like go cross-eyed if you want to, which I don't know if that recorded very well because it's hard to tell. It's hard to see myself being cross-eyed, and it may also give you a more different way if you look all the way to the right or all the way to the left. You may find that value, you prefer it or not. You can turn those on or off as you wish. Sync update, that's the last one I haven't covered for button-wise. Your two eyes will update. Like your two cameras will send data as fast as they send data, and this thing will process it as fast as you're sending it. And what it will do, if that value is currently set, like if it's set to false, like it is right now, whenever one camera updates, it'll generate a new prediction for both eyes. So new prediction for both eyes, new prediction for both eyes, new prediction for both eyes, and so on. Whereas if you do sync update, it'll wait until both cameras update before you get a new prediction. So if it's camera, then you get a prediction. So you may find the tracking there works better, but that has a tendency to increase your latency. It's kind of, your mileage may vary on that. Last things that you can do is you can force different cameras offline if you so desire. It'll also automatically fall back to, if one camera goes down, it'll switch to the other. You can also just turn your tracking off entirely and toggle it back on if you'd like. And you can see that a little bit better if you turn everything on independently. Like as I stand, if I were to close one eye, like you can see all the independent values. But if I were to go to my left eye, for example, and physically turn that tracker off, you can see, you can see everything will fall back to the other eye. Although the performance is going to be a little bit degraded, at least with the hardware that I have. Looking to one side can be a little bit tough for one of the trackers. Like, for my right eye's tracker, if I look all the way to the left, it's hard for my camera. For example, you can see my camera if I look all the way to the left. There's not a great view of my pupil. So the tracking can be a little bit degraded if you only have one eye turned on at a time. But if you have both, it'll use them both. And that's pretty much it. Once you got to this point, if you're using the software, if you're happy with the algorithm you train, you're happy with your configuration options that you've set up, all you have to do is just start the software. It'll keep all your settings. Just start the software, put on your headset, go to VR, you're done. Don't need to worry about anything else. That's pretty much it. So if you made it this far and you got this thing all set up, then good job. And have fun using the software. let me know if you have any trouble. I can try to take a look for you and see if I can figure out what's going on. I know that might be a problem for people who have like AMD, maybe people who don't have enough like RAM, or maybe if they have like an old GPU or something, they might have that kind of issue. I can possibly take a look at it. It all depends on like kind of my availability. But there you go. At this point, enjoy. Thank you for watching.